What's up, guys? It's Nathan here, and today you can see what I have here. Oh, sorry. I built another device for electrolysis. This is really dark. Just gonna get down here. Yeah, you can see instead of nails this time I used aluminum wire for electric fences, and I coiled it up so we should have a lot of surface area here. And the aluminum, I've tested this. It doesn't really dissolve into this as much. So yeah, I have it hooked up to this adapter. Let's go ahead and plug this in. Just right here. There, you can see. Oh, you can see that now. This is pretty dark. It's hard to see, but it's the top is actually foaming up from all the bubbles. You can hear that. Yeah, producing lots of hydrogen and oxygen this time too. If you look at my other one, it didn't actually produce very much oxygen because I was using salt as the electrolyte. The oxygen was combining with a hydrogen atom and a sodium atom, creating sodium hydroxide. And so we were left with chlorine gas and hydrogen gas. But now I used less salt, and this is really bubbling. Yeah, you can see on the top here, I have a little hole. Eventually I'm going to connect a tube to that, so I can capture the gases, which will be mostly hydrogen gas and oxygen gas in this one. The chlorine that is produced is mostly dissolved in the water here, so if you were to smell it, it would smell like a pool pretty much, which I've tested. Yeah, but yeah, there it is. You can see it's not changing color this time. When I use the nails, the anode, which would be the positive nail, just like in electroplating, where your anode would dissolve into solution here, the nail would actually dissolve in there, so that's what most of that green stuff is that was produced, which was iron oxide probably floating around in there. I'm not sure if the green color was caused by chlorine reacting to it. I have a suspicion it might be other contaminants of the water since I just used tap water. But chlorine may have. I don't know, the particles will probably be pretty small. But yeah, you can listen to that. Yeah, you can see it's really foaming up. Not much. Oh yeah, you can see here's the positive one. When I took it out, actually the negative one, it gets really, it gets really clean. Same thing, it's going from negative to positive. The positive one would get clean. Wait, no, negative one. You can see I just have it hooked up to this adapter. Yeah. Here it is again. You can see I've moved it to this area that's a little brighter, so you can see it better. There is some gray stuff, probably aluminum, floating around up at the top, aluminum oxide or something. So yeah, let's just haphazardly plug this in over here. There, you can see it now. Let's move over here a little bit. You can see there's lots of bubbles up there, and you can see the oxygen in there. Hydrogen's really bubbling. Yeah. I don't plan to have this running for long periods of time, especially inside my house, because filling my house up with explosive gas probably isn't that great of an idea. I mean, this would take a really long time to actually produce large quantities, but yeah. You can see it really isn't actually making that much oxygen gas. Probably because, like I said, it's combining with hydrogen and sodium to create sodium hydroxide. But yeah. Also, I don't really want to run it for a long time because this aluminum, I don't think it'll really corrode. But when I use the nails, I actually left it plugged in like for a really long time, and the positive nail like dissolved all the way. And yeah, so you can see it running here. There's still some salt in the bottom; it didn't all dissolve. But yeah, it's producing quite a lot. This coil definitely has this coil of aluminum electric fencing wire definitely has more surface area than those nails did. Yeah. If I used like metal plates or something, it would probably work even better. Especially if I sand them a little bit first, so they'll have more surface area. But yeah, I have built a similar device with a glass jar that I used. I put a hose in it, and it was working pretty well. Yeah. Hello, cat. I used salt for the electrolyte here, and sodium chloride, which is, as I said before, that's how they produce chlorine commercially. But yeah, you don't have to use salt, you just need something you need an electrolyte. So anything acidic or basic generally works. You can see up there, I'm sitting down right now, so you can't really read this, but I have some muriatic acid up there. I did try that as an electrolyte, and it worked fairly well. I also tried sodium bicarbonate, which you would probably know as baking soda, and it also worked. Yeah. You can see, I think there's it's supposed to be aluminum oxide or something. I'll have to figure that out. Floating around at the top. But yeah. But anything acidic or basic, you'll need as an electrolyte. This is because water is actually a pretty poor conductor of electricity on its own, and when you dissolve salt or whatever your electrolyte is into the solution, you'll have positive or negative ions floating around, and since they have a charge, that means they are electrically conductive, and that makes them suitable for electrolysis to happen, which, yeah. It turns out the process that that created this corroded aluminum floating around up here. Yeah, you can see. Well, you probably can't tell, but one of these is a little bit cleaner. Well, yeah, you can. But anyway, the process that formed this, I read about this. It's galvanic corrosion. So it's the same process that in batteries, like which would be the metals and the electrolyte reacting together to produce electrical charge. So this is the same thing pretty much, except for it's causing the aluminum to corrode up here, creating this stuff. Yeah, I'm pretty sure. Same thing, like, I don't know if you've heard of this, but there's a thing called a lasagna cell, I guess. It's pretty much if you have salty food like lasagna, if you store it in a steel pan with aluminum foil on it, you can get the same thing. It'll produce an electrical current corroding the aluminum, and yeah. But anyway, that's just what produced this. I think that's kind of cool, But yeah. Hopefully this stuff isn't like electrically conductive or anything, or it could short out my cell here. But yeah, that's just how that works. So yeah. Thank you all for watching, and I'll see you next time.